Okay, so I think my screen is visible, right? Yes.
Yes, yes.
Okay. Yeah, so let's begin. So I'm going to present the topic understanding MECC, vacuum and bloat. So this is actually my first presentation on Postgres, and I recently started learning Postgres. Okay, so for example, this is about me. I have overall 10 years of experience in database administration and work with multiple organizations. Mostly I worked on the support-based companies. I worked with only one product-based company, which is PhonePe. Apart from that, all the companies are support-based companies handling multiple clients. And I'm mostly like passionate about the open source databases. So far, like I work on MySQL, ClickHouse, and Postgres, and sometimes MongoDB as well. Yeah, I started my IT career at 2015 as a MySQL DBA, junior DBA, and yeah, currently started learning Postgres. So I tried my level best on this presentation, but yeah, I would like to hear from the experts, like if I missed anything or anything like uh, I missed. And this is the agenda of the topic. So this, like, I'm going to cover the MECC and the data tuples and the bloat and vacuum and AUTOVACUUM. So this is the major topic I'm going to cover. And yeah, of course, this is completely the demo session. Um, I I will work out in my terminal, and yeah. So actually, this is the flow. Um, like um, like so first of all, I would like to explain this MECC. Then I will explain this flow. Actually, MECC work difference in Postgres based in MySQL, if I am mostly the purpose of underlog is, let's say if I'm doing some transaction, I begin and I'm updating or deleting or maybe inserting some values. I need to, if I commit, that is okay. But if I want to roll back it, let's say I'm doing one update within the transaction, and I want to roll back it. In that case, that rollback, my MySQL needs to be aware of it, right? What is the older value? If I commit, then it is fine. Whatever written, that will be commit. The new value will be committed. But if I want to roll back, then MySQL will need to keep track of the older value. Then only when I give the rollback, it will update the before value, right? So those segments will be stored in the undo log. And also, when I use the repeatable read isolation level, I'm using MECC, multi-version concurrency control. So the transaction will keep the snapshot until the end of the transaction, right? Those things will also stored in the undo log. So mostly from MySQL point of view, mostly these statements, all these details will be available in the undo log. But here, what I feel is coming to the Postgres, this is completely different. So everything is stored, maintained within the table itself. There is no separate log. So how it is maintaining is it will create the newer version of the role. Let's say if I am updating one specific row, it is like it internally, it is not just update. It will delete the older row and it will create one new row, which means delete and insert both are happening. Okay, so this is what my understanding. And this posters in the MECC, it is maintaining the different version of the row. Okay, and let's say in the production database environment, if I have there are multiple users, right? Application, there are different users are using the DB, and maybe they can modify the same row from the different sessions, right? And so what MVCC is, so it will not, block the others maybe they can read or write. Whatever, when you connected and when you initiated the transaction, what is the view of that particular row? It will be available until the end of the transaction for you. Okay. Even maybe the other session, they can modify, like they do update, keep updating the particular row, but it will not impact your current session. It will take the snapshot, and the snapshot, when you initiate the transaction, that particular snapshot will be available for you until you completed the transaction. Okay, so this is simply, I will tell this is the MECC. For example, so this is one of the single server. I created 3 different sessions. Okay, in the first session, let's say I have this select star from 80. Let's say I begin one transaction here, and within here, like where ID equal to, let's say I'm reading the first row. Okay, and in the second session, this is the same server. Okay, same server. In the second session, I'm just going to update this value. For example, update 80 set like name equal to AA double A, where ID equal to 1. Okay, so I just so this is auto commit. I did not begin commit, so it is auto committed. This transaction is committed. But if I'm seeing this in the first session, this value is changed, right? Here it is, the value is changed to double A, but still I can see the single A value here in the first session. So this is what, like when coming to the Postgres, like it is maintaining the different versions. I will show this in detail. We have some hidden columns, so we need to explore that so we can understand this better. Okay, so this is some kind of example, like as I mentioned, when you initiated the transaction and when you initiated the select, what is the point of the data? It will be available for your entire transaction. Okay, fine. Now, I just want to walk through this flow. Okay, maybe I'm doing some update or delete from the application, or maybe I'm manually logging and doing this. And sometimes inserts also when it gets the rollback. Okay, I'm doing this operation, and Postgres create new version. Okay, old row is not removed immediately. Okay, so let's say I have one row. When I'm doing some update, as I mentioned, it will delete the existing row and it will create the new row. So which means internally one delete is happening and one insert is happening, and that row which is getting deleted will not be get removed immediately. Okay, we will see this in the practical example. Okay, and this old row becomes dead tuple still occupy space, and when it will dead means like it is the new row, and when I'm doing some update, it will comes to the, it will like demoted as a dead row, sorry, old row. And when it comes to the dead row means once the transaction is committed, then it will comes as a dead row. Okay, once the transaction is committed, it will come it will be considered as a dead row. Then it will not be visible like just doing the select star from. We need to inspect the pages. Okay, we will see that in detail. Okay, so new row, old row, dead tuple. Okay, tuple is the in Postgres, I think the row is called as a tuple. So new tuple, old tuple, and dead tuple. Okay, and dead tuple accumulate like once the table receiving lot of updates, deletes, when this happening, then there will be lot of dead tuples will be available, right? Then it will, once it is accumulated in a big manner, then it will be called as a bloat. Okay, bloat actually it will impact your performance. It should be clear. Okay, we will see that in the demo. Okay, and when the data affects the index also, it will affect because the data is pointed to the index page. That will also the index pointer, the older pointer. When internally the row getting deleted, tuple getting deleted, the same relevant index pointer will also invalid, right? So that will also invalid. So in that case, index bloat as well as table bloat, both tuple bloat, both will happen. Okay. Now, so as I mentioned earlier, everything is happening inside the table, within the table. But for the other databases like MySQL, it is not happening within the table. It is the separate log, which is called the undo log. It is happening. But within the Postgres, these all things are happening within the table. So when it happening, there should be a lot of unused spaces, right? Because when something deleted in the Linux level, it will be like still occupied, right? The space is still occupied. We need to, let's say in the MySQL, we have the fragmented space, right? We need to defragment it so that we can reclaim the disk space, right? So similarly, we have when we deleted or updated, then when the new version of rows are getting created, the old version of rows are that dead tuple. Dead tuples are still available. They are occupying the disk. Okay. So in this case, when I am running some statements against it, it will, of course, it will impact the performance, right? Now, to to clear this kind of spaces for the dead tuple spaces, we need to run the vacuum. Okay, so when we run the vacuum, it will just it will clear the thing and it will just create the holes. Still, you will not get the data disk space available in the disk. Okay, you will not you will not reclaim the disk space, but your table spaces the pages will be cleaned and the holes will be available, so that whenever you do the new inserts, that holes will be used and the new data will be occupied there. So you can just avoid the disk growth. Okay, so vacuum is one of the important things in the Postgres, because without vacuum, because you might do a lot of updates, right? And your application do a lot of updates. So in the Postgres, we already see that everything is happening within the table. So when you keep updating, but if you do not clear the space, then what happens? Like this will be pile up, right? This your disk space will be pile up. All this it will be heavily impact your performance. Your table will get grow, and like maybe you will get close to the disk, and you need to maybe add disk. All these things will happen, come together, right? So to avoid this, vacuum is very important in the Postgres. And yeah, you have two options: vacuum and auto vacuum. Or vacuum is something you need to manually run, and auto vacuum you can schedule it by enabling the auto vacuum on. You can schedule it. There are a lot of parameters available to fine tune the auto vacuum. Based on that, auto vacuum will keep checking your table and it will do the vacuum thing. Okay. Now, when you are doing the vacuum, what is the happening in the high level? Okay, it will find the dead tuple. Dead tuple means that older version of the rows, which is already there is no other transactions are relying on that, so it is committed, right? So that is considered as a dead tuple. Then it will remove the dead tuple, and it will also remove the related relevant index pointers. Okay, that is the index tuple that will also get removed. Okay, and there are two mapping. One is the FSM and another one is the VM. Okay, FSM means free space map, and visibility map, VM means. Okay, so FSM map means like it will scan the page and it will check any holes available in the pages. Okay, it should be updated, right? Because the main reason is when you have the holes, it should be updated so that the new inserts can occupy, I mean, fill that holes, right? You created the holes by running the vacuum, but if those holes are still not getting used, then there is no use of it, right? So whenever the new insert comes, that should use that holes, so that will be maintained by the FSM, free space map. And the another one is visible map. It is like it will check any dead tuples are available in the pages, because this is also important, because when you are running the vacuum, your pages, if your pages don't have any dead tuple, then you can just you can ignore that specific page, so your vacuum will be speed up. It will be get speed, right? You don't your vacuum, you don't need to check all the pages, right? So in that case, this visible map is important. Okay, so this free space map and visibility map both are like a very important thing when running the vacuum. Okay, so once all these things are done, like your space is like reusable. Not you reclaim the space, but it is reusable. Reusable by the new data, which is new, coming newly, the insights, like, right? So it will be reusable. So you can avoid the further disk growth, right? When you have the holes, it will use that holes for the new data. You can avoid the disk like growth. And the main thing is it will improve your performance as well. We will see that in the demo. Okay. And finally, of course, the better performance, it will like from the cache wise, your disk IO performance is, you will get the better performance finally. Okay, fine. Now, yeah, we already see this MVCC. We from the different sessions we can access. It will not block. It will not interfere, right? At the point when you are starting the transaction, what is the viewpoint? It will be available until your entire transaction. Okay. Now, to understand this better, we have actually posters have the hidden columns. There are a few hidden columns like xmin, xmax, ctid, and there are a few other columns as well. Okay, hidden columns that will give some useful informations for your debugging, all these things. Okay, so let's say we are going to see these three main hidden columns, which is xmin, xmax, and ctid. Okay, xmin means like it will define the transaction ID that insert the tuple, and the xmax means when it delete the tuple, it will update it. Okay, we will see that. And ctid means it will have the location of it. Okay, so just have this in my in mind. Let's see this. Okay, so for example, yeah. So let me close one session here. Okay, so I think accounts is not there. Let me quickly create it. Okay, so I'm just creating one table and one data here. So for example, select start from accounts. So we have one data ID equal to 1. The symbol data ID equal to 1 and balance is 100. Okay. Now I'm going to run. Let's say this is something we are trying to understand how this xmin and xmax is getting updated and how this MVCC is working using the hidden columns. We are trying to understand this. Okay. And so this is the actually, if you see here, begin, right? Okay, 1 second. And begin. So if you see here, actually this table have two columns, ID and balance, right? ID and balance, these two columns. But if you see this the other three columns, which I just, these are the hidden columns, which is for each table you will get it from the Postgres, and that is very useful for your debugging purpose. Okay, so I just printed 1 and 100, the same value appears here. Okay, now what I'm going to do in the next session, I'm going to create one more transaction. Okay, so for example, this is let's consider this as the next session and begin. And when I'm running this, it will print your current transaction ID. Okay, this is your current transaction ID, which is 1069. Okay, and then I'm going to update. So I'm going to update account set balance equal to, let me put some value there. I'm just going to update to 500. Okay, so currently the value is 100. Current value for the balance is 100. Now I'm going to update to 500, where ID equal to 1. The update is done. Now let me select this, and before this, let me commit this also, because we opened this transaction. I just committed it, and you can see the current value is 500, right? And this 1069 is the current transaction ID. That's what we get it from here, right? Transaction ID current, which is 1069. Before we initiate this update, we get this ID. And you can see this update ID is 1069 for the xmin. Now, let me do the select here. If you see, your x max is 1069. Okay, because this, let's say this update, as I mentioned, when you are doing the update internally, it will delete and insert. Okay, so here you can see this is deleted the previous value and now it is inserted the 1069 value. Okay, so because that is the newer value which we created from the update. Okay, now if I am, so if I'm doing this, after that, let me commit this. For example, let me commit this. So what we can see here, your data is same. When I'm doing the update in the different session, ID equal to 1 and 100, ID equal to 1 and 100. Both are same only. Okay, as we mentioned, this MECC, it will create the new version. But what it's telling in the Xmax, it just updated the new transaction ID. Okay, because any writes if happen within the transaction, it may conflict. So it just updated the Xmax ID, but still your data is same. That is the important thing here. ID and balance both are the same. Okay, now I'm just going to so what we see that when we do update, it will delete and insert, right? So there should be two rows, right? Two rows. So now let me do this. So we need to enable this create page inspect extension. Okay, I already enabled it. So when we enable it, we can get this information from this key page item. So just execute that command, okay, to get this information. So for example, now I'm going to execute this command here. You can see there are two rows. Okay, so this is the like older row. This is the older row, and here this is the new row, right? Because this is the latest transaction ID. Xmin is the transaction ID which will be created when inserting the data, right? So this is created, and this is our transaction ID 1069, right? And this is the deleted one. This record is like already deleted. This is the dead tuple. Okay, this is called the dead tuple. So what we have here, it should be like the older value, like this ID 1 and 100. Now we updated to this one, right? 500. This is already committed. So your new xmin will have this value 1 comma 500, and this is your older value. Okay, 1 comma 100. Now how we can verify, do we have any dead tuple or not? That we have the query to do. It will get the data from the stat user table. So if I execute this, you can see there are two rows. From when we inspect the page, we can find there are two rows. There is one active row, one dead row. Okay, active row is this one, right? Active row is this one, 1 comma 500, and the dead row is this one, 1 comma 100, right? Now we have this. So similarly, now we are doing the single insert statement. So we are seeing only one row. But let's consider this same scenario in our production environment. There might be a lot of DML statements, right? Lot of updates, lot of maybe delete, right? That can happen, right? So in that situation, this number will keep growing. Okay, when this number will keep growing, it will impact your performance. It will increase your disk usage, right? Because within the Postgres, it is maintaining the different versions, right? It is different. It is not having the dedicated file like MySQL. It do not have the underlog, right? But yeah, this within in Postgres, it is within the table. It is managing everything. So when the overdose happens, when it deads, you cannot refill it until you run the vacuum command, right? It because it is not available. It is filled in the disk. The deleted row is still there. If you want to get that particular space, you need to run the vacuum. Then only you will get the space reusable. The next insert will reuse that, right? So so currently we have this one, only one, because for our example we have only one. And here, like when you run vacuum, let's say vacuum this table name accounts, right? It is done. And if you see this, you can see this dead tuple will be gone. So now your space is available. So when it is like a holes. So whenever the new inserts happen, it will be filling it. Okay. Now this still your disk is not reclaimed. Okay. To reclaim your disk, you need to perform the vacuum full. There is one more command. We will see that. Okay, so this is like how this dead tuples are happening in your table, and when you are running the vacuum, it will create the holes. Still, you will not recover your disk space. Okay, to recover your disk space, you need to run the vacuum full so that it will rebuild your entire table. So during the rebuild, you will not able to access the table. It is completely like you cannot do the select or insert update, nothing. Okay, that is like a complete downtime for your particular table. It will just create the new data file and it will copy the entire data from here to there. Then finally, it will drop it, and so you will get the only the live rows will be copied from here to there. So finally, you will get the string data file when you do, but that will happen only when you are doing the vacuum full. Okay, that is mostly like a downtime operation. Okay, fine. So this is now we see this one thing, and the next one is, let's say I'm doing something and I'm rolling back the transaction. For example, let me quickly create this table and let me do this insert as well. Okay. Okay, so this previous one is already committed, right? Yeah, so this table is created and I just insert one record. You can see that ID equal to 1 is available now here. Okay, now yeah, let me write this select as well with the hidden columns and the live columns. Okay, you can see this is, and this CTID is, this is like on which page, number of page. The 0 is the page number or block number, and 1 is the offset number. Okay, within the page with the offset number. Okay, now this is done, and now what I'm going to do in the another session, I'm going to just begin, and let me delete this row. Delete from rollback. Yeah, only one row we have, right? I just deleted and commit. Sorry, not commit. Now, here, let me see this. You can see this max ID is updated 1072, which is the transaction ID of this transaction. Okay, this transaction. Now you can see I deleted. You can see this Xmax is updated already in the disk. It is already updated. Now instead of commit, I am doing rollback. Okay, instead of commit, I am doing rollback. And now let me execute the same command. You can see the same value. Now let me just commit this and do the yeah. Here you can see I did the delete within the transaction, but I did rollback. I did not committed this value, right? But still, if you see this, value, okay, 1 second. Okay, sorry, this is a different table, right? Accounts. So you can see this value. This I already rolled back, but still my Xmax value is not 0. It is still holding the transaction ID of the session where the delete executed. Okay, so still it is holding 0. Sorry, still it is not 0. The Xmax is still there. So now here what happened is, when I am already written, when I am doing this delete statement, the change is already done in the disk. So when I did the commit, then it is fine. But here I did the rollback. This, when I am doing this delete, this Xmax value will be written. Okay, it is already written. Okay. So now when I'm doing this rollback, it will just mark that row as a safe. It will not delete that row, but still it will not change this Xmax value. Okay, it will be keep there. Okay, so if you see this Xmax value, like why this is still there, if you have some confusion, then you can just execute this query. It will show you like what is the reason why it is there. For example, here if I do, this Xmax value is aborted, right? It is aborted. Aborted means like a rollback or something happens. Okay, it is not committed value. It is aborted. But maybe you have some question like when it will get removed, right? That is the next question. Okay, this is fine. This row is still live. So this particular Xmax value is not deleted. But when it will remove? So whenever you do some update on this row, then it will get removed. Okay, this row will go to the dead tuple, right? So it will remove. Otherwise, you have the only option. You need to do vacuum full rollback. Okay, you need to do this thing. Okay, when you are doing this, like you can see, this xmax will be, the counter will be updated, and because it will completely rebuild your table, right? It will just copy your live rows to the new table space thing, right? And your table space is also like the first one, zero first page and one offset. Okay, this is about rollback. So maybe you can see, like, maybe you get confused, like why this xmax value is not zero, why it is there. Maybe there is something with the rollback or some transaction interruption, something may happen. Okay, and to fix that, from my understanding, the only option is vacuum full. Otherwise, you need to update the specific tuple. When you are updating, then the current row will be go to your consider as a dead tuple. So the new value will be updated there. Okay, that will be zero. Fine. And this is about this rollback statement. And another thing is inset. Inset can create the dead tuple or not. Okay, it should, not all the insets, but when there is like a rollback happens, then it will do. Okay, I think I'm not sure whether I can. Yeah, let me ignore that. So this is like a rollback statement. We see this, right? This with the delete. The same thing will happen there as well. When you are insert, you begin and insert. Then if you are rollbacking the transaction, then that will also create the dead tuple. You need to rebuild. You need to do the vacuum on that. Okay, to reclaim the, not reclaim, just get that disk space to be reused. Okay, fine. Now, let me come to the next topic. I think this time thing. This is the why bloat can be the problem. Okay, that is the next thing. Let's say I mentioned here, right? When you have this dead tuple in our scenario, that is the single row. That is okay. Okay, but when you come to your production scenario, there could be lot of DMLs can happen, update or deletes, maybe insert with rollback. That may, there should be a lot of thing, right? So that your this dead tuple will be keep build up, and as I mentioned, it will impact your performance due to the disk space. All these things, it will impact your performance. Let's see how it will impact. Okay, I just created this real-time scenario. So I'm just going to create one table. Um, uh, okay, let me drop table. I'm just dropping the existing table that I created for my testing. Okay, so I just created one table. Now I'm going to insert some data, just bulk data like 5 million records. I'm just inserting. It should be happen within 15 seconds, I think. Okay, so once that is done, we will see the size of the table. Okay, let it complete. Yeah, it is done. And now let me check the size of this table. It is almost 673 megabytes. Okay. Now I'm going to delete 90% of the data from that particular table. Okay, let's say 90% means it is 50 lakh, means 45 lakhs of data I'm going to delete. Okay. So I'm just creating more dead tuple. That's it. That is the intention here. Okay. So let the delete happen. And in the next query, I'm just going to check the table size again. Yeah, this is completed. Delete 45 lakh records are deleted. Now I'm checking the table size again. You can see before also it is 673 MB. After deleting 90% of data, still it is 673 MB, right? There is no disk, recovery, right? Now let me check how much dead tuples are available here. We know this. This is the 45 lakhs. Only 5 lakhs is the live row. Okay, fine. This is done. Now, this is like, let's see how it will impact the performance. Okay, so this all okay. Now I'm just clearing the screen. Now I am enabling the time. So each query will report the time, how much time it executed. Now I'm running one count of star for the same table. If you see, It's running almost. I think it will take some 8 to 15 seconds. Let's see. Yeah, it taken 9 seconds, 9.6 seconds, right? Now let me run the vacuum on this table. Vacuum is happening, and finally, so what will happen when we run the vacuum? It will just free up the spaces, right? Dead tuple. It will remove the dead tuple, right? Now let me run the select count of star. The same statement. Now you can see this is reported like milliseconds, like 2.5. It is kind of 0.025 seconds something. Okay, so let's see. Previously, so this is like how it impact your performance. This bloat values, like dead tuple. The accumulated of dead tuple is called as a bloat, right? Bloat. So when you have multiple bloat on your table, like I'm not sure how to say it. When you have multiple dead tuple on your table, this is the real example how it will impact your performance. A single count of star command, you can see take 9 seconds on your table with the dead tuple. But when I'm running vacuum, this is like how much the vacuum is helpful on the performance wise, right? So after running the vacuum, your count of star is very much like reduced. Like it is less than a second, like half, not even the half, like a quarter of the seconds, like right. So this is how the blot impact your performance. So this is what we are suggested. Like it is recommended to have the auto vacuum enabled on your production environment, so that your tables will be keep checked based on your threshold what you configured. It will keep running the vacuum on your system, right? Cool. And I think okay, so I have this also practical thing, but like a time consuming. Let me explain this theory. Okay, and this vacuum will impact when you have the long running queries or the broken replication. This threads will impact your vacuum. Okay, so when you are, let's say I just do the select thing. I just selected some data in the another session, but I did not committed that. Okay, in that case, if my another session I am doing the vacuum means like because my here the transaction is still open, right? So vacuum will not work on that. Okay, so you need to make sure there is no open transactions when you are running the vacuum. Okay, and also when you are running the, as I mentioned, vacuum full on your table, it will completely block your all the operations like read and write, everything. It will be blocked. So that is completely the downtime for your table. Okay, table. I'm not sure. Maybe we have any other tools like from MySQL point of view. Like when you do the direct alter to rebuild the table, we have the copy algorithm, but we have the other tools like online tools like PT Online Schema Chain, Ghost. We have different tools. I'm not sure that Postgres we have any tools or not. But the inbuilt thing, this vacuum full when you are running, it will completely block your read and write operations, and it will not allow anything you can do. Okay, because it needs to create the new data file and it will just copy the live rows from here to there. Okay, that is the one thing. So this is also I thought to do the simulation, but yeah, it is fine. And this vacuum full, as I mentioned, this is do the access like entire operation. It will the access exclusive, but still, when you are running the vacuum, still at the end of the time when when it needs to truncating the empty pages, it will it will do this access exclusive. That, but that is a very short of time. You may not feel it, but yeah, it will do. Vacuum will also do. And also, as I mentioned, risk of the neglecting the vacuum, right? As I mentioned, this bloat accumulation. That is one of the major thing that we see in the real time, right? This performance thing, and your disk space will increase. All these things are there, right? So you need to the auto vacuum is the thing. You need to make sure you need to enable that in your production environment. Okay, and this transaction ID wrapper end. Okay, so this is actually I did not tested it, but let me tell you this theory wise. Like ID can be maximum stored 200 million something, like a 2 byte of 32, right? That maximum value we can store. But when we reach that particular transaction ID, Postgres will not have the room to proceed the further transaction, so it will create the downtime. It will impact more. So we need to run the vacuum freeze to fix this. But yeah, that will taken care by the auto vacuum. So yeah, that is a one thing. So these all things will be happen. So it is always recommended to enable the auto vacuum in your production environment. And also this we have a lot of variables available in the fine-tune. I also gone through the one of the blog from Jobin. He for the Percona. He and Avi both were written on 2018. I found that blog is very much helpful. I thought to incorporate the parameters to here, but actually I have very less of time. Even because I need to spend at least some 5 to 6 hours to understand that blog because we have a lot of information there, lot of parameters are explained. So I strongly recommend that blog. I will also go through it. Maybe I will do some presentation on that later. Okay, so yeah, this is about the topic today I have. Yeah, I would say from this topic, I just thought to explain this bloat carefully because as it is impacting the performance, I thought to explain that, and also importance of enabling the auto vacuum and also fine tuning that, right? So these are things are important when you are running the Postgres. And I really wonder this undo log thing, that everything we are maintaining within the table space, that is something quite new for me. Yeah, that's it.
This is a great demo and a session for a first-time speaker, Shakti. Really appreciate it.
Thank you. Thank you very much.
Awesome. Any questions for Shakti? With Jashita and Akhil, you have a quick break coming up.
Yes, sir. We will take a 10 minutes break. So that, Sri, you have a couple of questions in the chat if you want to reply to it.
Okay, let me check. Okay, reindex concurrently will auto vacuum does not renew index bloat. You must use reindex. Okay. Yeah, thank you. Actually, I had some suggestion. Thank you for that.
Very cool. 11:30 back then.
We will be back by 11:10.
Good.
It's
Thank you,
11
folks.
o'clock.